everyone, I hope everyone is doing great. So I'm here with another video. In this video I'm going to talk about software engineering, the definitions, types, programs and much more. But before I start the video, I would like you to like and share the video and do not forget to subscribe. So let's proceed towards the video. So basically, software is more than just a program code. A program is an executable code which serves some computational purposes. Well, software is considered to be a collection of executable programming code, associated libraries, and documentations. Software, when made for a specific requirement, is called a software product. Engineering, on the other hand, is all about developing products using well-defined scientific principles and methods. So, what is software engineering then? Software engineering is an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. The outcome of software engineering is an efficient and reliable software product. So here are some of the definitions. IEEE defines software engineering as the application of a systematic, disciplined, quantifiable approach to development, operation, and maintenance of the software. That is the application of engineering to software. The study of approaches as in the above statement. Fritz Baer, a German computer scientist, defines software engineering as software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and work efficiently on the real machines. Now let's talk about the software evolution. The process of developing a software product using software engineering principles and methods is referred to as software evolution. This includes the initial development of software and its maintenance and updates till the desired software product is developed, which satisfied the expectation requirements. So basically, the software evolution starts from the requirement gathering process, after which developers create a prototype of the intended software and show it to the users to get their feedback at early stage of software product development. The users suggest changes on which several consecutive updates and maintenance keeps on changing to. This process changes to the original software till the desired software is accomplished. Even after that, user has desired software in the hand. The advancing technology and the changing requirements force the software product to change accordingly. Well, recreating the software from scratch to go one-on-one with requirement is not feasible. The only feasible and economical solution is to update the existing software so that it matches the latest requirements. Software evolution laws. Lemon has given laws for software evolution. He divided the software into three different categories. One is S-type, the other is E-type, and then there is a continuing change and self-regulation. So basically, the S-type is static type. This is a software which works strictly according to the defined specifications and solutions. The solution and the method to achieve it both are immediately understood before coding. This S-type software is least subjected to the changes, hence this is the simplest of all. For example, calculator program for mathematical computation. So there is a P-type, that means practical type software evolution law, according to which this is the software with a collection of procedures. This is defined by exactly what procedures can do. In this software, the specifications can be described, but the solution is not obvious instantly. For example, gaming software. Then comes the E-type Embedded type. The software works closely as the requirement of real-world environment. This software has a high degree of evolution as there are various changes in laws, taxes, etc. in the real-world solutions, for example, online trading software. Now we come to the Etype software. Well, Lyman has given 8 laws for the Etype software evolution. Continuing change is the first one. An Etype software system must continue to adapt to the real-world changes, else it becomes progressively less useful. Increasing complexity is the second law. As an E-type software system evolves, its complexity tends to increase unless work is done to maintain or to reduce it. Third one is the conservation of familiarity. The familiarity with the software or the knowledge about how it was developed, why was it developed in that particular manner, etc. must be retained at any cost to implement the changes in the system. So then comes the fourth one, which is continuing growth. In order for an E-type system intended to resolve some business problem, its size of implementing the changes grows according to the lifestyle changes of the business. So the next one is reducing the quality. Any type software system declines in quality unless rigorously maintained and adapted to a changing operational environment. Then we talk about the feedback systems. The E-type software system constitutes multi-loop, multi-level feedback systems and must be treated as such to be successfully modified or improved. Then the other law is self-regulation. E-type system evolution processes are self-regulating with distribution of product and process measures close to the normal organizational stability. So the average effective global activity rate in an evolving E-type system is invariant over the lifetime of the product. Software paradigms. Software paradigms refer to the methods and steps which are taken while designing software. There are many methods proposed and are in work today, but we need to see where in the software engineering these paradigms stand. These can be combined into various categories, those each of them is contained in one another. So software evolution is the programming paradigm that is a subset of software design paradigm, which further is a subset of software development paradigm. And now let's see what is software development paradigm. This paradigm is known as software engineering paradigms, where all the engineering concepts pertaining to the development of software are applied. It includes various researches and requirement gathering which helps the software product to build. It consists of requirement gathering, software design, programming, software design paradigm. Thus, the paradigm is a part of software development and includes design, maintenance, programming paradigm. So this is all closely related, and this paradigm is related closely to programming aspect of the software development. That includes coding, testing, integration, need of software engineering. The need of software engineering arises because of higher rate of change in user requirements and environment on which the software is working. And a large software, so it is easier to build a wall than to a house or building. Likewise, as the size of software become large, engineering has to step to give it a scientific process. And then we talk about scalability also. If the software processes were not based on scientific and engineering concepts, it would be easier to recreate new software than to scale an existing one. So that was some information about software engineering. Software engineering, its programming, some of its rules and laws. and paradigms. So that was all for today's video. We'll see you soon in the next video. But do not forget to like and share the video, and do press the bell icon to get notified for each new video. And if you are someone new to the channel, kindly subscribe. Till then, take care. Bye bye.